Whisper, buy 100 shares of Apple. And sure enough, you see it's parsed the action there, and right there in my interactive brokers count in the bottom right hand side, you see there is a market order for 100 shares of Apple stock. And right there you see a pop-up indicating that 100 shares of Apple stock has been ordered. I could also say, Whisper, sell 27 shares of NVIDIA. And sure enough, right there, you see that 27 shares of NVIDIA were just purchased at market. The market is currently closed right now. I'm not risking any money on this whatsoever, but I think it's a very interesting example. So for this demo, I was able to take OpenAI Whisper that we use for speech recognition. I was able to use the OpenAI API to actually parse the natural language text that was transcribed from OpenAI Whisper. I was also able to use prompt engineering in order to send a prompt to GPT-3 to extract the named entities that I mentioned. So NVIDIA and Apple were mentioned in my text when I was speaking. And I also extracted the number of shares and an action on whether to buy and sell. And then finally, I added the extra bit of figuring out how to record from my microphone and sending that sound over to OpenAI Whisper to kick off the entire process. Combining that with my knowledge of interactive brokers, I was able to actually place a trade with my voice. All right, so let's break down how this application works and the different pieces of code that I had to write to put this all together to implement this idea. So the first bit I have is the requirements. And so these are the different Python packages that are required to execute this program. And so we have sound device here and Wavio and SciPy. These bits were necessary for the microphone recording. So the sound device is able to look at the microphone on your laptop, for instance, and knows all the details about the hardware and how to record a WAV file based on that. Secondly, you'll see here I have OpenAI Whisper that we've installed in video number 2 of this series. What that can do is take an audio file and transcribe it into text using speech recognition. Right here we have IBN Sync and Nest Async IO. As I mentioned, we're using Async IO and the Interactive Brokers IBN Sync library to execute trades against an Interactive Brokers account. And then finally here we have OpenAI, which is the Python package for OpenAI. This is going to let us call GPT-3. And so what we can do with GPT-3 is use our prompt engineering techniques to extract name entities and numeric quantities. And also, if a word is a little bit fuzzy, like buy and buy, right? There's all these words that sound similar, like B-U-Y, B-Y, and B-Y-E all sound similar when I say them. And so if Whisper for some reason gets that wrong, we can still use GPT-3 to process this text and map it to a very specific action. Also, as we learned in prompt engineering, we can do things like sentiment analysis. So we could take an entire sentence, classify it as positive, negative, hawkish, or dovish, and things like that. And so we have a lot of power at our fingertips when we take audio, turn it to text, and then use language processing to process that text and do cool things and return that response as JSON. So this application consists of 3 parts. The first is the recorder. So the recorder is what's responsible for recording audio from my microphone. So you see I've imported those first 2 libraries, sound device and Wavio here, and I have a frequency and a duration. Now I want to give credit to where I got some of this from. This guy, John Zoltan, contributed this to the OpenAI Whisper discussion on GitHub. And so there's some open source code here. He implemented a slightly different way. And so this is where I got the idea for the microphone code. So you see he's reading in messages and then he's writing it to a single WAV file here, right? And he's using multi-processing and just doing it inside of one Python file here. So he's doing both the recording and the transcribing in a single file. So he had a different purpose here. I think he was trying to build a question answering bot, but what I did was just take the microphone bit and then I kind of made it my own, but I only needed a few lines here. All I really wanted was a timestamp, and I want to just do a recording and then write that recording to a WAV file. So the duration in seconds is the length of time you want to record. And so if I say I want to record for 20 minutes straight, then I'm not going to have the file ready for OpenAI Whisper to transcribe. And so what we're doing is transcribing in small chunks, right? And so it'll write a 5-second WAV file, then another 5-second WAV file, and record my voice in order, right? And so if you look inside the recordings directory where I'm recording this, you'll see there's just a bunch of 5-second chunks of WAV files here. And so this actually adds up to a lot of files. That's how I did it right now. Maybe you can think of a more clever way to do this. And now once I have those recordings, I need them to be transcribed. And so we have the second part of the program, which is the transcriber. What that does is look at the recordings directory with all those WAV files. It loads OpenAI Whisper, which we've already discussed how to do. I created a list here called transcribed, and what this is going to do is keep track of the files that we've already transcribed. Once a file is already transcribed, we're going to add it to this list, and if it's in that list, we don't need to do it again, right? And so in this loop here, what I'm doing is checking this recordings directory, and I'm going to list the files in that directory sorted by their last modified time. And so if there's any new files in that, it's going to grab the last item of that list, which is the latest recording and the file name. And so if there's a new recording in this recordings directory and it's not in transcribed, we haven't transcribed it yet, then we know that we need to transcribe this file. And so we just use the Whisper code here to load the latest recording and a couple lines to convert it to a spectrogram and then decode it and then write it to a file. And so this code right here is all in the OpenAI Whisper documentation. And so here I have a unique thing called the no speech probability. And so what you'll notice sometimes is that Whisper, if you don't say anything and it keeps recording and then you send it these WAV files with maybe a little bit of noise, it's going to try its hardest to interpret that as text, right? It's actually trying to transcribe whatever you send. And you'll see these hallucinations, which is one of the slightly risky things about doing something like this. And so if you were watching the transcription earlier, I think there was a thank you in there. So it just said thank you randomly, even though I didn't say thank you. And that was because I think there was probably a pause or some extra noise in there. And it was like, what is that? Oh, maybe it's a thank you. And since I think Whisper, how it works, I think it's actually trained on all these YouTube videos. And so every once in a while, you'll see something weird like a thank you for watching or something like that, which I always say at the end of a video. I sometimes say thanks and thanks for watching and things like that. So you'll see some occasional weird things in there. But what you'll see is it has a certain, I believe it's a certain confidence of the probability that it's actually real speech versus not real speech. And so what I did here is use this no speech probability, and there's this confidence level that it's speech or not speech. And what I did is use this to filter it out. And maybe you could optimize this threshold a little bit. I think this worked pretty well. And so if it is actually, most likely speech, then I write the text out. And so I print the text on the screen just so I could show it in the demo. And then I write that text to a transcript file. And so I append to this transcript file. And so if you open up this transcript here, you can see it's just appending lots of text to this transcript file. And then after it's transcribed that one WAV file, it's appended to our transcribed list so it doesn't do it again. And then the whole process starts over. So I keep recording, keep generating WAV files, and then keep transcribing them and appending them to this text file. So once I've spoken all these words into the microphone and all those words have been transcribed into this text file as plain text, how do we actually interpret that text and have it get translated to some real world action? Well, that's where the broker comes into play. This broker is going to take this text. He's on the other line of the phone call and saying, hey, what are you saying? Let me take action based on this. And so if you scroll down in the broker file, what I have here is this function called run periodically. I'm not going to do a whole lesson on async IO. It might take a half an hour to an hour. So that's why I mentioned all my previous videos. I've discussed all these topics before. But what this is doing is running a function periodically, a periodic function. And so every second, 5 seconds, 1 minute, we might want to perform a particular piece of logic. In this case, I want to perform the function check transcript. And since this is attempting to be near real time, I want to do this very frequently. So every second, I want to execute this check transcript code. And the main logic of this application is inside of check transcript. So I've imported OpenAI because I'm going to be calling out to GPT-3, and I've also imported the libraries for connecting to interactive brokers. So while this application is running, I actually have Trader Workstation open, and for those unfamiliar, that's the client for interactive brokers, and I can actually write computer code to execute trades and have it talk to the interactive brokers client right here. So the bulk of the logic in this script is handled in the check transcript function here. What I do is keep the last occurrence of a stop word or a command word. I'm calling it the command word. You'll see I have many constants that are configured in this config file. So if you go in config.py here, you'll see I have my API key. You would have to use your own, a transcript file. I'm specifying to write the transcript to this text file. I have a symbol table. So right now, just for this demo, I'm just mapping a few different stocks to the appropriate symbol. You could do further natural language processing or a big giant symbol table of all the stocks you want to be able to trade. There's a variety of ways you could handle this. For this, I'm just hard coding a few different stocks to demo. I have a command word called Whisper. So I said, Whisper, buy 100 shares of Apple stock. You could change this command word to whatever you want. And I also have the prompt I'm going to use for GPT-3, which I'm about to talk about. So what I'm doing here is finding the last occurrence of the command word whisper. And so if I say whisper buy 100 shares of Apple, I'm taking what happened from whisper to what happened afterwards. So I'm finding the occurrence and getting the rest of the text. So I'll know the command is buy 100 shares of Apple, right? And then I keep track of that last occurrence so I don't parse the same command over and over again. Once I have that command, I can send that over to GPT-3 and I can engineer a prompt to parse that text. And so how did I determine which prompt to use? Well, I experimented in the OpenAI playground as we did in the prompt engineering video. And so it takes a while to figure out how you want to parse this text, how you want to talk to it to get it to return the right thing. So what I did is say, return the name of the company and the quantity in the text below. If the text contains the words buy, or buy, return buy for the action. If the text contains the words sell, or sale, return sell for the action. Return the result in JSON format. You can modify this and change it however you want. I started with a prompt like, find words that start like buy or rhyme with buy or things like that. There's all kinds of different stuff you can do to try to handle these different edge cases. And so since GPT-3 is an auto completion engine, as we discussed in the prompt engineering video as well, you can give it a sample of how you want the output to be. And so this is a very powerful technique. As I showed, you could send it that you want a JSON response and what the structure should look like so that the language that's the response you get from GPT-3 could actually be interpreted by a computer program. So I'm saying, give me a structured response. And so I want an action, I just want the company, and I want the quantity, just like this. And when I click submit, GPT-3 is able to extract the named entity NVIDIA. It's able to extract the action, which is sell, but it interprets that as sell, just like I told it to. And I'm able to extract a numeric quantity. I'm not saying I've covered every single possible edge case here. There's probably lots of things you can think of where you'd have to make a more specific prompt. But for the purposes of this demo, I could send it a variety of things and it was working pretty well. And so feel free to experiment with this and make it better. As you know, once I have a structured JSON response, Python can easily take that response and convert it and store it in variables and do whatever I want with it. And so you can see right here, I've built my prompt here. And so in my config file, I just took the instructions I gave it, return the name of the company like that, return JSON format. I sent it in my output format, just like that. So you can adjust that if you want a more complex configuration. And I also sent in the command that came from my voice, that came from the transcript. Once that was done, I just send an API request to GPT-3. It returns a response. I parse that response. Since it's JSON, I can load it right into a response dictionary. I mapped the name of the company it returned to my dictionary here that had my stock symbols. Technically, you can maybe figure out how to parse stock symbols. I just did a big mapping like this. So you could dynamically pull all the symbols, tradable symbols in the S&P 500 or NASDAQ 100, whatever, generate this table here. That's not a big deal. And then so once that's done, I just call Interactive Brokers. I've done a tutorial on Interactive Brokers already. So that's an hour-long tutorial if you want to learn about that. So I got the symbol from our symbol dictionary that's in the config file. I instantiated a new stock object. If I wanted to use Interactive Brokers to trade options, I could do an option object, could do a futures object, Forex, all these things. I don't trade every single thing, but here I'm just using stock for simplicity. And then I'm just doing a market order right here. And so I'm doing a market order. Since I have an action for sell or buy in my response dictionary, I pass it over, and I can also pass it the quantity for this market order. And then I just place the order just like that. And like magic, I'm able to programmatically interact with my broker, hence the name Interactive Brokers. So there you have it. I've demonstrated a way where you could use OpenAI to create your own voice commands to do whatever type of task you want. And so in this case, I've used it to trade stocks with my brokerage account. You can feel free to run with this, take the code, create whatever you can think of. I'm sure people have tons of creative ideas out there, and I just share all the code for free on github.com/hackingthemarkets. Knock yourself out, take my code, do something cool with it, and I hope you learned a lot from this. So thanks for watching. See you in the next video. Thanks.